Welcome to Cognitive Spirals, exploring the latest research into consciousness, cognition, and machine intelligence. Today, we're diving deep into a topic that's been causing a bit of a stir: propositional interpretability in AI. It's about whether our current AI systems, especially the really complex ones, are actually thinking or just giving us very convincing statistical outputs. Yeah, exactly. I mean, we've seen these massive leaps in what AI can do, but do they understand it? That's the big question. Are they just mimicking patterns, or are they actually grasping the underlying logic, the propositional relationships between concepts? It's a really crucial point, and I think we're starting to see the limitations of just brute force methods in deep learning. I mean, these models are amazing at pattern recognition, but their internal representations are often opaque. We can't really see how they arrived at a certain conclusion, and that's not really true understanding, is it? It's more like a black box, really. I agree that lack of transparency is a huge issue. It's like, you can ask these models a question and they'll give you an answer, but they're not really explaining why they're giving you that answer. It feels like they lack a certain level of reasoning, a certain capacity for logic. They're incredibly powerful statistically, but that's different from understanding, I think. It's like knowing that when you press a button the light turns on doesn't mean you understand how electricity works. Exactly. And this propositional interpretability, or the lack of it, affects everything. If you can't see how the machine made a decision, how can you trust it in critical situations like medical diagnoses or autonomous driving? It's not just an academic problem, it's a very practical one too. Right. I mean, think about medical diagnoses. If an AI recommends a treatment, you want to know why. You want to know the logical chain of reasoning that led to that conclusion. Saying, well, it's just what the algorithm predicted isn't very reassuring, especially when lives are at stake. But I do think we're on the right path with deep learning. It's just that, we need more data. We need bigger models. I mean, the progress we've seen in the last few years has been astonishing. It shows that if we just keep pushing, we're eventually going to crack it. I'm not so sure about the more data approach, though. It feels like we're just throwing more and more pieces at a puzzle without understanding how they fit together. It's like we might end up building more and more complex, but still fundamentally opaque systems that are maybe even harder to interpret. We need systems that can explicitly represent and manipulate knowledge in a way that mirrors human reasoning, and I'm not sure deep learning, in its current form, can provide that. And it's not even just about explainability, it's also about the kind of intelligence that we're creating. Yeah, I totally agree with that. Deep learning feels like it's brute force, right? It's about finding correlations, but not really understanding the causal relationships. It's like, okay, it sees that most people with a headache and a fever are sick, but it doesn't understand why, or that some people can have a headache without a fever. It lacks that deeper layer of reasoning. And that's where I think focusing on the spatial and temporal representation is key. The way we think about the world, the way we map it in our minds, is critical and is something that's missing from current AI. For example, consider something as simple as understanding how a car moves in the world. It's not just a series of positions. It's a whole dynamic and the car's relation to its environment. That's interesting. I think you guys are touching on something really important, this idea of the internal representation of information. I mean, for us, the world is a unified space-time thing with different symbolic representations for different things. We can go from a visual image of a car to the propositional statement, the car is moving, and we can do that effortlessly. But that ability to map between representations feels really missing in current AI. It makes me wonder if we're just creating very sophisticated lookup tables rather than actual intelligence, Well, I think that's a bit harsh. I mean, look at how well these LLMs can generate text. They're not just spitting out pre-programmed phrases, they're actually creating new sentences, new paragraphs, even entire stories. That requires a certain level of understanding, doesn't it? It might not be conscious understanding, but it's still quite impressive. It's like they might not understand the rules of grammar explicitly, but they've absorbed them and can use them effectively. More data and more sophisticated architecture will eventually lead to true understanding, We are already seeing LM perform reasoning, but they do it probabilistically. This will turn into deterministic logic with more data. You just wait. But that's the thing, they're operating on a probabilistic level, not a logical one. It's about predicting the next word in a sequence, but not necessarily understanding the meaning behind those words. It's like they can write a love poem, but they don't really understand love. And that goes back to the original point of our conversation. They are doing the what and not the why. It's almost like a really sophisticated parrot. I think we need to move past these purely statistical approaches and build systems that can understand the semantics of language, that can grasp the relationships between concepts and reason about them logically. And that's where neuro-symbolic approaches might be really valuable, if we can get them to scale. Yeah, I agree. The fact they're predicting the next word shows a lack of understanding of the deeper structure, right? The way humans use language is embedded in a rich context, a spatial temporal context, and current AI systems are not really capturing that. It's like they're processing language in a very linear, sequential way, when actually it's a highly complex and structured thing. And it's the structured part that encodes the meaning. So when you say, like, the dog ran under the table, you automatically understand the spatial relationship between those objects and have some kind of idea of the underlying event. That whole representation is missing in a deep learning model, and it makes reasoning extremely hard. It will be very hard to learn that with data alone. It's like you can't learn calculus by just adding numbers together, right? That's a brilliant analogy, actually. You can't learn calculus by just adding numbers together. So, it seems like our reliance on these massive data sets might actually be obscuring the problem. If we are simply optimizing for prediction and not for understanding, we will never truly understand the mechanisms of intelligence. So, maybe the focus should be on understanding the neuroscientific principles of how we represent and manipulate knowledge, and then designing AI systems that operate according to similar principles. I wonder how much we can leverage hierarchical temporal memory, a model of the hippocampus, to develop AI models that are better at long-term memory and context. Perhaps, instead of mimicking the patterns, we should really be trying to mimic the elegant structure of the brain. But what about the speed? I mean, these LMs are so incredibly fast. They can process huge amounts of data in a fraction of a second. I saw some interesting work that pointed to the speed of processing being part of the problem. It seems that they are thinking so fast, they are not exploring the solution space thoroughly, and that this might actually be a hindrance to understanding. But surely speed has to be a desirable property in an intelligent system, right? I mean, we want them to be efficient, and they are definitely that. We should be able to refine the approach. If exploration is the key, we should work on the mechanisms of exploration itself, not slow down the processing. I think this thinking fast approach might be masking a fundamental flaw in its approach to understanding. What do you think? I think that speed argument might be a bit misleading, The fact that they're so fast might actually be part of the problem. It is like they're just jumping to conclusions rather than carefully exploring the problem space. The focus on speed and processing power seems to be pushing out the deliberative aspect of thought. It's a bit like rushing through a complex novel and then expecting to fully understand the message and underlying meaning. And that actually ties in with this whole idea of propositional interpretability. The lack of it means that it is hard to evaluate the model's claims, and that it makes it very hard to tell if it understands a problem, or is just finding a superficial fit. For instance, how can we introduce a conscious or deliberate step in the learning process? I think that slowing down the thought process could be a step in the right direction. There must be something about the balance between speed and deliberation that is key here. Okay, so we're seeing this convergence of ideas, which is really interesting. The speed, the lack of interpretability, the lack of translation between symbolic representations, all these things seem to point toward a fundamental issue with the current approaches to AI. What we really need to be able to do is bridge the gap between the raw, messy sensory input and the symbolic reasoning and logical structures that we use to make sense of the world. The brain seems to be really good at that, at seamlessly moving between different levels of abstraction, different coordinate systems. It makes me think that it is not enough to simply mimic what we see on the surface level of intelligence, but we must also try to understand the elegant structure that creates intelligence. Yeah, but I think we're making a mistake if we completely throw out the deep learning baby with the bathwater. The progress in recent years has been just too great to dismiss. We just need to figure out how to incorporate this more structured representation into these neural networks. Maybe we need to start looking at hierarchical learning architectures or a more nuanced type of reinforcement learning, not simply discarding the brute force. I believe that we will eventually find a way to get these AI systems to understand the world like we do, and I think we are actually closer than people think. And in terms of the thinking fast question, perhaps it's just that they haven't learned yet when to slow down. I mean, we also think fast when we know the answer. The problem is they might be thinking fast even when they don't, and this is the part that needs to be refined. I think the point is not to discard the advances made with neural networks, but to move beyond the limitations of purely data-driven approaches. I mean, there are ways of combining neural networks with symbolic reasoning, and these hybrid approaches could be a good way forward. For instance, how do we develop neuro-symbolic algorithms that can both reason logically and learn from data efficiently? And, maybe we also need to rethink the whole speed thing. I mean, maybe slowing down the thought process is actually a part of what it means to be intelligent. Maybe what seems like a limitation, like deliberation, might actually be a necessary part of what makes human intelligence so good at finding solutions. And that's where we need better exploration mechanisms, not just brute force searching. Absolutely. The point isn't to abandon all the progress, but to recognize the inherent limitations of the current approach. We need a fundamental rethink about how we're designing these AI systems. We need an algorithm that understands spatial temporal relationships and the different coordinate systems that we use to represent those, We need to explicitly model the dynamics of the world and allow the AI to actually move between different mental frames. And on top of that, we need to reevaluate the notion of speed. Maybe the answer isn't in processing more data faster, but exploring the problem space more strategically. And that's going to require a different kind of algorithm, one that actually understands the deeper logic of the world. Perhaps an algorithm that is capable of switching between different coordinate systems may be what is missing. So, it sounds like we're all in agreement that we need to move beyond this purely statistical brute force approach. The idea of focusing on the way the brain represents and processes information, particularly spatial temporal information, seems to be key to building more truly intelligent systems. It's not about speed, but about understanding. It's not about prediction, but about reasoning. And it's certainly not about data alone, but about creating intelligent structures to organize knowledge. It is all really interesting. Okay, so taking from that for future research, I would still argue that we should continue to explore the architecture of deep neural networks. We should be looking at more efficient algorithms for optimization that move past the current bottlenecks. We could perhaps also investigate how the systems can learn to slow down and explore properly. Perhaps we should also study the brain's mechanisms of exploration. We might also need to investigate hierarchical learning and reinforcement learning. I'd be more inclined to explore the possibilities of hybrid neuro-symbolic systems. We need to design algorithms that combine the learning abilities of neural networks with the reasoning capabilities of symbolic systems. I think more research is needed on how to create algorithms that can learn new knowledge and then translate this into usable knowledge. We need to really think about the architecture and to investigate the nature of the representation itself, and not simply the processing speed. My focus would be on developing algorithms that explicitly understand spatio-temporal relationships, with a strong emphasis on coordinate systems and how to translate between them. I think that these will be key to a truly intelligent AI, and I suspect that we need to think outside of the current deep learning framework and consider alternative mathematical frameworks. Perhaps we also need to focus more on modeling the dynamics of the world, rather than just the static information. I am very interested in the question of frames and how the brain switches between them effortlessly. And this, I suspect, is an important component that is missing from modern approaches. And I think we need to explore these ideas of representation. How can we move between different symbolic representations? How can we integrate what we know about neuroscience and apply those principles to AI? How can we introduce hierarchical temporal memory to be able to handle long-term memory and context? How can the models learn to explore effectively, rather than just think fast? I think we've got some really interesting directions for future research, and I think we've managed to unpack the challenge of propositional interpretability. Well, that's all we have time for today on Cognitive Spirals. Thank you for joining us, and we will see you next time for more explorations into the mind and machine.